Good evening, everyone. Welcome to 113th video on misconceptions in physics. My name is Ratankar Rao. I teach physics in an international school in Bangalore. My hobby is to make these kinds of videos. Misconceptions in physics is a concept that we derived from one of my colleagues and as well as some of our students and alumni, wherein we thought, why only teach concepts? We can also teach about how these concepts can be incorrectly applied. And as a result of it, you make mistakes in numericals. And that's what is the result of these videos. If you want to watch all my videos, you can refer to my website, which is shown over here, which is ratankar.com. You can visit this website and you will be able to see all the 100 videos, 110 videos so far what has been done. This video would be aired across, would be posted across in the website maybe tomorrow or day after tomorrow. Once I think maybe around 4 to 5 videos comes across, I can just edit the website and put it across. Okay, thank you for being with me in this journey and helping me out to do lots of videos. In fact, students are the ones who help me out to do these videos. The several students whom I have, some of them are my alumni himself. They say, okay, sir, my child, he attempted this particular problem. He was not able to get this in his classroom and he did not understand. Can you please do it across? What was the misconception? And so on. So that's what I take up such kinds of videos, such kinds of problems, and then solve it. Okay, coming back to this problem without wasting much of time. So today's video is on comparing distances, usually height of falls, which are in opposite directions. You can say, okay, we have done similar videos earlier also. And if I look at the previous videos that we have done so far, the first one video was on comparing distances, which when two different stones or two different masses of the different masses were being dropped from one of the buildings, and how does the height differ with respect to time? That's what we have done. And then the second video was on comparing the velocities and the accelerations, wherein we found out like what happens to the velocity and what happens to the acceleration. And thus we came to know that acceleration, change in acceleration for two objects which are being dropped from the same building, it is zero. Change in acceleration would be zero. It means both the objects would be experiencing the same acceleration. And if you look at the velocity, the velocity will remain a constant. Okay, the difference in velocity, not the velocity. Velocity changes with time. The velocity, relative velocity between two objects remains a constant. And that's what we have proved it also here. It's a very important problem in one of the JEE mains papers. The same question was been asked. I took up this problem over here. And then yesterday, if I remember, we had done one problem on something like if a particle falls from a certain height, when the velocity is v, and if the velocity becomes 2v, then what happens to the particle's height? What is the height from which the particle has fallen? This was, in fact, given by one of the students. So this problem was also solved. And usually most of the students assume that the height is proportional to velocity. So why this misconception comes here is because we know that distance of fall, okay, they related to velocity because they consider the distance divided by time is equal to velocity, which is incorrect here. The reason is because that particular problem, that particular solution can be applied only when, okay, when the particle moves with a uniform velocity. Else you will not be able to apply it. Okay, here the particle is moving with an acceleration. Whenever there is an acceleration, distance is not proportional to the time. Okay, and distance is not even proportional to velocity. Okay, just a moment. Okay, I'm back. While so this is what was the misconception. And now let us look at the next part. This is problem which many students make a mistake. 99% of them. Okay, without solving, if you just look at the problem and then assume it logically, you will definitely make a mistake here. So the problem is like this. A stone is allowed to fall from the top of a tower of 300 meters height. You have a tower, and from this height, you are dropping it. The height of the tower is 300 meters is given. And at the same time, another stone is projected vertically up from the ground with a velocity of 100 meters per second. Now from here, you're throwing it like this. Find the ratio of the two distances, distance of the first stone by distance of second stone, which means let us say in a given interval of time, okay, so this stone comes like this stone also goes upwards. Now, what is the ratio? So what the students usually consider is that they think that this stone will go to half of it and this stone will come to half of it. So as a result of it, this is x over here, then this is h minus x over here. This anyway, this distance will be equal to this distance. So x divided by h minus x has been asked. Since x is nothing but h, okay, which could be around 150 meters, and this is also 150 meters. So they give the answer as 1. Okay. So what was the assumption? The assumption is that they think when you throw an object upwards, it can go only half the distance. When you throw an object, when you drop an object from the top, this will also move by the same distance, which is incorrect. How do you prove it? So in physics, until unless you don't prove things mathematically, you cannot assume just like this. Okay? Which is totally incorrect. So let us solve this problem. Now, how do we solve this? Okay. So when a particle is being dropped from here, the distance it covers in a given unit of time is x is equal to ut plus half gt square. Half at square. Let me write down half at square. Half at square. Now, I will consider this as my x-axis and this as my y-axis, which means any particle that comes down is negative. Okay, it has a negative displacement, negative velocity, negative acceleration. In that case, I will say the distance fallen by this particle is nothing but minus x, which will now be equal to u. What is u? U is nothing but the initial velocity. When you drop it, the initial velocity is going to be 0. So it should be 0 plus half into what is a? A is nothing but the acceleration. Which acceleration? Acceleration due to gravity, which should now be equal to minus g multiplied by t square. Thus, I can now write x is equal to half g t square. This is what is the equation. Let me write first equation. Now, what have we done? We have only analyzed the motion of the particle when the particle has started from here and starts to come down. We have analyzed this part. Now, let us look at this part, the upward motion. Now, as I suggested, anything that goes upwards is positive and anything that comes downwards, we are measuring it as negative. So, therefore, now if it is going here, now if the total distance is h over here, if this distance is x, this distance should be h minus x. In the earlier example, we had chosen, okay, or the student had thought that x should be equal to h minus x, which is not true. Okay, let us see why it is not true. Until unless I don't prove, I will not be able to claim that. Okay, now let us see that. So now I can now say, let me use the same equation of motion for the upward motion. H minus x, this is a displacement of the particle, which is positive, should now be equal to ut plus half a t square. Once again, I'll write the same thing. Now, what is u? U is nothing but initial velocity. You have said initial velocity is 100 meters per second. So I will write this as 100 times t plus half. Now, what is a? Is it accelerated? No, because you see, when you throw a particle, the moment the particle leaves your fingers, it is only under the influence of gravity, which is always acting downwards. Okay, so you are not giving a force here, you are giving an energy. Okay, what is that energy? Kinetic energy. Now, as the particle keeps on going upwards, the particle loses its kinetic energy or it converts its kinetic energy to potential energy. Okay, that's the reason why it keeps on going up, height and going up and up. Okay, so therefore it goes over here, it reaches this point. So therefore, the only acceleration that comes over here is nothing but the negative acceleration, which is gravity. What do you mean by negative acceleration? It is putting a brake. Okay, it is trying to pull it downwards. It says, hey, I'm not going to let you go upwards. Okay, I'm going to pull you downwards. So therefore, this should have been minus g, and this is t square. Let me write just like this. Now, from this expression, okay, let me call this equation number 2. From here, I know that x equal to half gt square. I already got this. Okay, I'll substitute this one equation here. I'll write this as h minus half gt square is equal to 100t minus plus into minus minus half gt square. Now what will happen? This minus half gt square, this minus half gt square goes up. So what am I left out with? I am left out with h is equal to 100t, right? Now let us substitute the value of h. What is the value of h? 300 meters. So let me substitute 300 is equal to 100t. This implies t is equal to 3 seconds. What is it we have got now? We have got that when you throw a particle, from here, after 3 seconds, this particle would have met with the first particle, which is coming from the top. Okay, they meet at a junction here, and it takes 3 seconds for them to meet over here. That's what we have got. I have not told whether they collided. Okay, it crossed, nothing I have told. I just said that when do they meet? We have got this. Does it answer a question? No, it doesn't answer a question. 3 is not the answer here. Okay. The reason is he has asked you about the distance. What distance? We have to find this x minus x by h minus x. Now, how do I find it? That's the next question. So towards it, let me take this from here. I don't have space. Let me write it down here. We put a boundary here. This is fine. Okay. Now x by h minus x. Let me write down x divided by h minus x will now be, what is x here? X is nothing but half gt square. Let me substitute. Half gt square divided by, what is h minus x? 300 minus half gt square. I would have done much more easier also. I would have just substituted this value and got the answer. Anyway, let us do it like this itself. So half into g. What is g? 5. Okay, 10, sorry, 10. G equal to 10. So let me substitute that value. I get this as 5. If you get confused, what I will do is, I'll write this as half into 10 into t square. What is t square? 3 is t equal to 3. I'll substitute here, which is 9, divided by 300 minus half into 10 into t square. Once again, 9. So let me solve this. This will become 2, 10, 2 5s are 10, 5 9s are 45. So this will become 45. And this will become 300 minus 2 1s are 2, 2 5s are 5 9s are 45 once again. So which is now nothing but 45 divided by 255. Right? Now you see what has happened. Now h minus x. What is the value of h minus x? H minus x is this, which is nothing but 255 meters. And what is the value of x? 45 meters. 45 meters. Now you see, the particle which you dropped from the certain height, it has only traveled a distance of 45 meters. It has not traveled 150 meters here. Okay. But this particle, when you threw it up with a speed of 100 meters per second, has traveled a larger distance. Agreeable. The reason is because you see, here you are throwing it with an initial velocity of 0 meter per second. You are dropping it, not throwing. But here you are actually throwing the particle. Okay. So this will travel lesser distance. This will travel more distance. And thus you see the ratio between these two should be 45 by 45 divided by 255, which if you want, you can solve this and you can write this as, how much will this be? 5 9s are 45, 5 5s are 5 1s are. The answer should have been 9 by 51. What did the student get? The student got an answer equal to 1. Okay. So this is how misconceptions arise. Okay. Never imagine, never assume, never put across your logical reasoning until and unless, okay, there is some amount of math present for you to solve the problem. Okay. So this is what we need to look into. So every problem in physics should be solvable, provided that you need to locate the appropriate parameters. Thank you, friends, for watching this video. In the next video, we will see more on such kinds of misconceptions. The entire series that we are going to watch, at least for the next 15 to 20 videos, okay, it will only be on comparison problems. Comparison problems are the most important problems in physics. In many branches of physics, you will see such kinds of problems, and most of the students make a mistake in this. Okay, thank you. Do share and subscribe to this channel for getting more updates like this. Thank you.